Now, in the previous lecture, we discussed about how to formulate a research problem. So whenever we have research problem in mind, it's just a crude concept. It's a proposition. It's something hypothesis that you have in your mind. Now, at this point of time, what happens? It is not a measurable parameter. Measurable parameter means whenever you have your crude idea in mind, you require certain measurable parameters. Now, Priya just now told that she wanted to study impact of social media on different businesses. But this is just a crude idea. There are no measurable parameters. When she's talking about businesses, there is subjectivity. There is a lot of subjectivity when she's talking about the businesses. There are so many businesses, right? There are so many businesses which are available in the Indian market. So whether she's talking about some health related business, finance related business, marketing related business, or automobile related business. So it is not clear from this particular research problem. So it is just a research concept in her mind that she wants to assess the impact of new media or the current social media on the growth of business. But the measurable parameters are missing here. So variables are what? Variables are nothing but these are the measurable parameters. When she will add certain businesses, suppose she's adding finance business. Finance business means these are the banks. When she will go to bank and she will collect the data, so that becomes her variable. So measuring finance data or measuring automobile industry data, that becomes her variable. I took example in the previous lecture about the efficacy of electric vehicles on the air pollution. So whether really these electric vehicles are helpful in reducing air pollutants. So this is the concept. This is the crude idea. This is a crude research problem. Now, at this point of time, there is a lot of subjectivity. Suppose I say that I want to assess the impact of electric vehicles in relation to air pollutants. Now, there are so many air pollutants which are currently available, like there may be PM 2.5 particle level, PM10 particle level, carbon dioxide level, carbon monoxide level. So when I say that I want to study air pollutants in relation to electric vehicles, what type of air pollutants I want to study? Whether I want to study PM 2.5 particle level. Some of you will think that I want to study PM 2.5. Some of you will think that I want to study PM10. Some will think that you want to study carbon dioxide or sulfur dioxide levels. So there is variability. When we put our research title, when we put our research problem or research concept, it is just a crude idea and the measurable parameters are missing in it. Measurable items are missing in it. So variables are what? Variables are these measurable parameters. Now, when I say, suppose I say that my title is impact of electric vehicles on reducing or impact of electric vehicles on air pollutants. If I specify that I want to assess the impact of electric vehicles against petrol vehicles on the levels of PM 2.5 particle level. Now this is very specific. Which variable I have taken? I have taken only one variable, that I have taken PM 2.5 particle level, or I can take multiple variables like I want to study impact of electric vehicles on PM 2.5 particle level, PM10 particle level, carbon dioxide, sulfur dioxide, carbon monoxide, all these air pollutants I want to study. Now it is very specific. Now you will understood what I want to say, in what context I want to say, because I have added something measurable parameters. I cannot measure air pollutant. Okay, how can I measure air pollutant? I can measure the levels of PM 2.5 particle level. I can measure the levels of PM10. I can measure the levels of carbon monoxide or carbon dioxide, and then I can say that pollution is more on a higher side or the pollution is on lower side. So variable is nothing but variable is dissection of your idea, dissection of your research problem into measurable parameters. When you have your measurable parameters, these are called as your variables of your study, right? So in the previous lecture, we discussed about research problem, formulation of research problem. It was based on what? It was based on your review of literature. So in that, what you do, you study the existing literature, you find out the gap in the existing literature. Gap means what other investigators have done and what other investigator couldn't do it, or what is not done, or what is missing in the literature. So we try to find out the gap in the literature while formulating our research problem. Now, the next step of after your research problem, after formulation of research problem, is to dissect your idea into different variables. Variables means because they are measurable parameters. Always your research problem is a crude idea, crude concept. This is not measurable parameters. These are not non-measurable parameters. you have to have certain measurable parameters. Why you want to have measurable parameters? Because you want to collect the data. What is the ultimate aim? Ultimate aim is to find out solution to your research problem. What is my research problem? I want to assess impact of electric vehicles on air pollutants. Means I want to assess that whether after introduction of electric vehicles, whether there is a reduction in air pollutants or the air pollutants are increasing. So that is my research problem. I should have a solution. Solution in the form of what? In the form of statistical data, statistical solution by applying certain test of significance. For that, I will require data, but the data will be not on air pollutant, but it will be on measurable parameters like PM 2.5 particle level I can measure, like maybe particular cubic millimeter, 100 cubic millimeter, 120 cubic millimeter. Similarly, PM10 particle level I can measure, carbon dioxide level I can measure, carbon monoxide level I can measure. Based on that, I can decide that air pollution is on higher side or it is on moderate side or it is on lower side, right? So that is the purpose of variables. In the previous lecture, when we discussed about research problem, it is always a crude idea. It is always a crude concept. It has come from the review of literature or gap in the review of literature. You formulate it after studying the review of literature, right? Now variables, the function of variable is to measure those parameters. Means we require certain measurable parameters, right? So those measurable parameters are called as variables. In today's lecture, we will discuss about these measurable parameters, and they are the most important part of your research study. So today's variables, we will discuss in terms of what is variable, how to transform your concept into variables. It is very important step. Priya just now discussed about her research concept, but she has not yet transformed her research concept into variables. She has not identified her variables because her literature studies left. So once she find the gaps in the literature, she will have her own variables, like whatever new things she want to study, she will have add those variables. Then classification of variables we will study, and classification of measurement scale. Okay. So what is variable? There are lot of definitions which have been mentioned in the literature, or a lot of books have a lot of definitions. These are some of the definitions which will help you to understand what is meant by variable. I have already explained you what is meant by variable. We will go into the details of definition part. An image, perception or concept that is capable of measurement, hence capable of taking taking on different values, is called as variable. So whenever you have a research problem in mind, it is some image you have in mind. You have some perception in mind. You have some concept in mind. My perception is that electric vehicles will help to reduce the air pollution, or hydrogen vehicles will help to reduce the air pollution. This is my perception. But this perception I have to measure because I want to prove or disprove. Okay, means I have to prove my perception that I am right. For that, I will collect the data, right? So that concept requires certain measurable parameters. And these measurable parameters are capable of taking different values. Different values means what? Suppose I conduct a study on electric vehicles and air pollutants for a period of 3 months. During 3 months, I took the levels of PM2 PM10 and other air pollutant levels every day. So every day the values will change, right? It is not a static value. Suppose for PM2.5 particle level, today if it is 110 cubic millimeter, tomorrow it may be 90 cubic millimeter, day after tomorrow it may be 150 cubic millimeter, or even after 1 week it will be 170 cubic millimeter. So there are variations in the values. You will have different values. When you will have different values for your parameter under study, that is called as a variable. So variable is simply nothing but these are the measurable parameters. The parameters which can measure that you can measure are called as variables. Second definition, a concept that can be measured is called as a variable. It's very easy to remember. Whatever concept, whenever you have a concept and when you transform that concept into measurable parameters, it is called as a variable. According to Kurlinger, a variable is a property that takes on a different value. Just now I gave you example about PM2.5 particle level or PM10 particle level. So maybe for today the level is 120, tomorrow it will be 170, day after tomorrow it will be 200. So it will take different values, right? So variable is a property. Basically, it is a measurable parameter that will take a different values. Last definition, a variable is a symbol to which numerals or values are attached. Numerals means numbers or some value is attached. Okay, so variable is nothing but it's a symbol. So in my case, I have PM 2.5 particle level, I have PM 10 particle level, and some numerals are attached. Numerals or values are attached means what? Which numerals or which values? These are numbers. These are numbers in terms of the PM 2.5 particle level. That is 120 cubic millimeter, 170 cubic millimeter, 110 cubic millimeter. All these are the values, right? So variable is a symbol to which numerals or values are attached. So this is simple. So what you have to remember, variables are nothing but these are the measurable parameters. These are the measurable parameters for your research problem. You have to convert your research problem into measurable parameters. Otherwise, you won't be able to collect the data, right? You won't be able to apply the test of significance. You won't be able to apply the different statistical measures or parameters. So for the application of different statistical measures or parameters, you require these variables. Any doubt in the understanding of what is variable?
Sir, I have a doubt, sir.
Yeah, yeah.
Sir, in clinical settings, say accidental and emergency, the number of patient. So disease will be the variable, or how we will say ki these things are variables. Like measurable things are there. Particle size is measurable, uh, but in the clinical setting, how we decide ki these things are variables?
Disease means suppose somebody is having excess blood pressure.
Okay,
So
sir.
blood pressure you measure. So that blood pressure is a measurable parameter. Some person is having excess blood sugar or some person is diabetic. So how do you diagnose diabetes? Maybe you will measure HbA1c or you will measure blood sugar levels, okay, fasting or postprandial. So that is these are the variables. Like when you say this person is diabetes, so diabetes is a disease or
So, like
uh,
sir, I have chosen a topic, in a sparring for the boxing or say in a close combat event, the which disease is more common and how to prevent mm, that uh, that thing via intervention. So,
Mhm.
what will be the variables, sir?
See, all the diseases like see because of pax boxing there is trauma, right?
Yes, sir.
Yeah, so because of trauma induced by boxing, not because of other factors. Trauma may be because of a
Correct.
number of reasons,
Correct,
but
sir.
trauma
Correct.
due to because of boxing, and because of that boxing trauma, which diseases or what type of fractures or what type of diseases develop. All your diseases will be because of boxing, whatever trauma related diseases develop. All those are your
Very.
variables of study. Can
Thank you,
you
sir.
name one? Can you name one like?
Sir, mm, uh, cut over the eyebrow, cut over the
Yeah, that is your. Yeah, 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 yeah. That
lacerated
is
wound over
the
the lips, concussion.
mm, yeah, yeah.
Concussion is also a part of. Thank you.
Variables like yeah, all these are variables. Like whatever diseases you are taking, giving the names. All these diseases are your variables.
Yes.
Diseases because of particular incidents, like because of this trauma from boxing.
And in the accidental and emergency cases, how many patients in a day, or if I want to say ki these number, matlab, in a accidental emergency, trauma comes or the normal uh, regular patients like common cold or which type of patients are coming. So different type of diseases will be my variables.
Yeah, like suppose uh,
And in
common
case of
diseases.
if I am studying about only for the hypertension or say a particular disease, so the identifying features like a hypertension, I have to measure the blood pressure. For the diabetes, HbA1c and the
Yeah, yeah,
fasting sugar,
yeah.
and that will be my variables.
Yeah, I will give you a simple example. Suppose you are heading fever OPD and different patients are coming to fever OPD. So you will segregate patients. Some patient will be because of some kind of viral infection. Some patient will be because of corona infection. Some patient will be because of some bacterial infection. So you will divide into different parts. So the people because of coronavirus infection, people because of influenza virus, or people because of some other routine viral infections, or maybe because of bacterial infection. All these are your variables because you will have different plan. You will have a different method of data collection and different treatment plan for each of these subjects.
Thank you, sir. Got it, sir. Got it. Thank you.
Okay. So we'll move to the next part, that is concept and variables. Your research problem is always your concept, and the measurable parameters are always variables. So what is the difference between these two? Concept is always a subjective impression. Subjective means there is no uniformity among all the people. Suppose there are 30 people in the class or 35 people in the class. When I say I want to assess the impact of electric vehicles on air pollutants, so it is a subjective impression. It is a there is subjectivity. How do I want to assess? There is no objectivity in it. Means when I am saying I want to assess the electric vehicles, but whether I want to assess only electric vehicles or I want to compare with other petrol or diesel vehicles or hydrogen vehicles or CNG vehicles, it is not clear. Okay. Second part, I am saying that I want to assess the impact of electric vehicles on air pollutants. So here also I am not very specific about which air pollutants. Some of you will think that I want to assess PM 2.5, some will think that PM 10, some will think about carbon monoxide or sulfur dioxide. So it is always subjective impression. So when I have a concept in mind that I want to assess impact of electric vehicles on air pollutants, that is a subjective impression. Means the understanding is not uniform. The understanding is not clear among different people, right? But when you have measurable parameters means it is always objective because it is measurable through a degree of precision. So what is variable? I will say that I want to assess the impact of electric vehicles against petrol or diesel vehicles on air pollutants like PM 2.5 particle and PM 10 particle. These are the measurable parameters. Means variables are measurable parameters. There is objectivity. Objectivity means everybody will be on the same platform. When I say I want to assess the impact of electric vehicles against petrol and diesel vehicles on PM 2.5 and PM 10 particle level, all of you will understand what exactly I want to study. So that is the work of variables. Variables will give you objectivity. Variables will help you to reduce the subjectivity of your concept. So concept is always subjective impression. Variables are always objective impression. Next part, concept has no uniformity as to its understanding among different people. So just now I gave you example, like different people will think in a different way when it is a concept, right? As such, it cannot be measured. So concept cannot be measured. There are so many concepts. Okay, so just now Priya gave example about impact of social media on different businesses. She didn't mention about which social media. There are so many social medias available that she didn't mention, and there are so many businesses which are available. So there is subjectivity among all of us. When she gave the name of topic like impact of the social media on different businesses, or what aspect of businesses in terms of income, in terms of profit, in terms of growth, what she wants to talk, which part of business she wants to talk, and which business. So all of us are confused, right? So that is a subjective impression. So that is a concept. She has a concept in mind, but she has not yet decided the variables. When she will decide the variables, we will get clear idea what type of businesses she want, what aspect of business she wants to study. So all the details we will get after studying the variables. So variables will provide objectivity for your study. Variables will help you to reduce subjectivity, or variables will help you to reduce different understanding, different levels of understanding, or it will provide uniformity in understanding among all the people, among all the scientific people, right? Variables are measurable through a degree of precision. Means you can have a certain degree of precision. I can measure PM 2.5 particle level, PM 10 particle level with degree of precision. Like I will have equipment and it will measure for today, tomorrow, day after tomorrow, and maybe for next 3 months. And it varies from scale to scale. So we have different kinds of scales. So that we will discuss, and we have 4 types of scales, and that we will discuss in detail under measurement scales, right? And from variable to variable. So basically it provides objectivity. It provides objectivity in terms of understanding. So all of us will be on the same platform. These are some of the examples, like when we put research title or research problem, we put in terms of effectiveness. So what was my thing? Effect, I want to assess effectiveness of electric vehicles, or somebody wants to study consumer satisfaction or impact of particular thing. Like just now Priya gave example about impact of social media on different kind of businesses. So all these are concepts. Okay, all these are concepts like effectiveness, satisfaction, impact, excellence, high achiever, self-esteem. All these are concepts. and which are not measurable, right? These are not measurable. We have variables like gender. I can measure how many males are there and how many females are there in this class. Okay, so I can measure with a degree of precision, whether I measure or someone else measure. Suppose there are 10 males and 10 females in this class. If I measure or someone else measure, the number is going to be same. There won't be a subjectivity. Suppose we have 5 people who measure how many males and how many females are in the class. This will not happen that some will measure 10, other will measure 9, someone else will measure 8. All will be on the same thing. Like all will say that there are 10 males and 10 females in the class, right? Similarly, attitude. We can measure attitude of a population, attitude of population regarding a particular issue. During Corona, we have seen so many different types of attitude of a population. Attitude of for using mask, attitude for maintaining social distancing, attitude for using sanitizer. So that attitude we can measure. Attitude of a population, attitude of a sample, that is a measurable parameter. Age is again a measurable parameter. If I come to know date of birth for everyone in the class, I can say, or I can measure the age, right? I can measure the age in years or months or days, right? That is possible. Income is again measurable parameters, like you will know how much income you are getting per month. Weight is again measurable parameter. Height is measurable parameter. Religion, all these are measurable parameters. Measurable parameters means with objectivity. Suppose I say that I have this particular height. So if someone else's measure, it will be the same. There is no objectivity in that, right? Suppose if all of you tell date of birth, if I calculate your age, or if someone else is calculating your age is not going to change. There is no subjectivity in your age, right? So that is the variable. Variable will provide objectivity. You will have objectivity for your study. And concept is always your research problem, your crude research concept, your crude research idea, right? That is the concept. Any doubt in this? The difference in the concept. So your research problem is your concept and your variable or measurable parameters are your variables. Now coming to the classification of variables, we have basically 3 ways of classifying these variables. This is the classical method of classifying the variables. First is a causal relationship. Causal relationship means cause and effect relationship. Okay, so cause and effect means I will introduce electric vehicles, so the levels of air pollutants will go down. Means I have introduced a cause. Electric vehicles are the causes, and effect will be seen in the form of reduction of air pollutants. So this is a cause and effect relationship. So first is based on cause and effect relationship. That is independent variables, dependent variables, extraneous variables, and intervening variables. Based on the study design. So study design is also important part. We have active variables and attribute variables. Based on the unit of measurement, we have qualitative variables and quantitative variables. So qualitative variables are the variables which are expressed in terms of text or words. Okay, so these are qualitative variables. The quantitative variables are the variables which are expressed in terms of numbers or numerals. Okay, so those are quantitative variables. For my study, which are the quantitative variables? PM 2.5 particle level, because I can measure 120 cubic millimeter, 170 cubic millimeter, 180 cubic millimeter, that I can measure. So these are the quantitative variables. And for if you want to assess the attitude of using mask, or attitude of maintaining social distancing, or attitude towards using sanitizer, so that these are the qualitative variables. Means you will ask someone, are you using mask? The person will answer yes or no. So that is a qualitative variable. Are you maintaining social distancing? Yes or no. Are you using sanitizer? Yes or no. So the answer will be yes or no. It is not number, right? So these are the qualitative variables. Continuous variables. Continuous variables means these are these have a continuous scale. Continuous scale means what? Suppose you have a scale. Scale means measurement scale. So when you see measurement scale, maybe small measurement scale will have from 1 centimeter to 12 centimeter. Now, if you see the distance between 1 and 2 centimeter, there are 10 subdivisions. 1.1, 1.2, 1.3 up to 1.9, and then 1.10 is your 2 centimeter. So it is a continuous from 1 to it is 1.1 is possible, 1.2 is possible, 1.3 is possible. Now, if you say that age, my age is continuously increasing by seconds, by minute, by hour, by day, by week, by month, by year. It is continuously increasing. So you can express in that term. It is continuously increasing. But if I want to calculate, or if I want to measure the number of males and number of females in this class, can I say that there are 9.5 males and 11.5 females in this class? It is not possible. There will be either 10 males and 10 females, or 9 males and 11 females. That is possible. But 9.5 males and 11.5 females, it is not possible. So that is your categorical or discrete variables. So continuous variables means it's a age. Age is a good example of continuous variable. It is like a continuous scale, right? And categorical means these are discrete variables. When I say that I want to count the number of students in this class, I will have a count in terms of discrete numbers and not a fractions. I will never get fractions for for this particular variable. Okay, so where the fractions are not available, it is called as discrete variables, separate variables. Okay, and when the fractions, when you express values in terms of fractions, these are the continuous variables. Now categorical or discrete variables are again subdivided into constant variable, that is one category, dichotomous variable 2 category, and polytomous variables 3 category. Now all these things we will discuss in detail in today's lecture. Now coming to the first classification, that is based on the causal relationship. Based on the causal relationship, we have 4 variables, and these are independent variable, dependent variable, extraneous variables, and intervening variables. What is independent variable? Independent variable is the cause. Cause means what? I want to introduce electric vehicles in the market, or I want to study the impact of electric vehicles. So electric vehicle is a cause. If I introduce electric vehicle, there is possibility that air pollution will go down, or the levels of air pollutants will go down. Means if I introduce electric vehicles, that is the cause. What will be the effect? The levels of air pollutants will go down, right? I cannot say that today levels of air pollutants are low, means electric vehicles are there in the market, means vice versa is not possible. So independent variable is independent. It will have its impact on the dependent variable. It is a cause. Independent variable is always cause for occurrence of some phenomena, for occurrence of effect, for seeing the effect. So when you introduce an independent variable, when you study impact of independent variable, you will see the change. You will see the effect. Right? So independent variable is the cause supposed to be responsible for bringing about change or changes in phenomenon or situation. So what is situation? Air pollution is the situation, right? The cause is electric vehicle. I am introducing electric vehicles, so levels of air pollutants are going down. There is change in the phenomena or situation. So independent variable will have its impact on the dependent variables, which are the air pollutants. Means independent variable is the cause. And what is a dependent variable? The outcome or changes. So what we study outcome variables. Now, Priya just now discussed about her research problem. In her research problem, what were her outcome variables? She has not decided it, which are her outcome variables, but she want to assess the impact of social media. She has already decided her independent variables. Her independent variables are, that is the current social media or modern social media and conventional media. Conventional media means newspaper or magazines, right? So that is the cause and effect she want to study on different businesses or different types of businesses, right? So independent variable is the cause, impact of social media on different businesses, on the growth of different businesses. Okay, so you are using current social media, you are using advanced social media, so your business is growing, you are getting more profits, you are getting more clients, right? That is the independent variable. Dependent variable means outcome or change. So outcome variable is what? Increase in the business, increase in the clients, increase in the satisfaction level of clients, reaching more people. That is the outcome. Outcome because of you have your impact of independent variable. Impact of independent variable means you have increased your exposure to social media or social media advertising. Similarly, in my case, which are my dependent variables? The air pollutants. Air pollutant means PM 2.5 particle level, PM 10 particle level, carbon dioxide, carbon monoxide. All these are my dependent variable. Their value, their measurements are totally dependent on the vehicles, type of vehicles which are used. That is the electric vehicles or petrol vehicles or hydrogen vehicles or CNG vehicles. So what type of vehicles you are using? that will impact my outcome in the form of air pollutants. So all the air pollutants are my dependent variables. So dependent variable is what? The outcome or change or changes brought about by introduction of independent variable. Means independent variable will have its impact on the dependent variable, and that impact you have to study. So in the this type of research, what you do, you assess the impact of independent variable on dependent variable. Priya will study impact of the independent variable, that is social media, on the dependent variable, that is different aspects of businesses. Okay, so you will study impact of one variable on other, but one variable is independent. It is not dependent on other variable, and other variable is dependent on independent variable, because independent variable will have its impact on dependent variable, and that impact you will measure. And that is your study, measurement of impact of independent variable on dependent variable. Extraneous variable. Extraneous means what? Several other factors operating in real life situation may affect changes in the dependent variable. These factors not measured in the study may increase or decrease the magnitude or strength of relationship between independent and dependent variable. So extraneous variable means what? Several other factors. Several other factors means what? I am giving example. Suppose I am conducting study of electric vehicles and air pollutants in university area. But just opposite university, there is industrial belt. Now what is happening? These petrol vehicles and diesel vehicles are eliminating PM 2.5 particle levels. Now I am introducing electric vehicles. But at the same time, there are industries which are just opposite university campus. These industries are also eliminating PM 2.5 particle level, PM 10 particle level. They are also increasing the levels of air pollutants. So suppose I conducted this study for 3 months. In these 3 months, I found that the levels of average levels of air pollutants are before introduction of electric vehicles. If I measure the levels of air pollutants, if I found it as 120 cubic millimeter. After introduction of electric vehicles for 3 months, if I found the levels are 80 cubic millimeter. But really, am I studying the impact of independent variable on dependent variable? Here, whether I am getting correct information in terms of impact of electric vehicles on air pollutants. There is some other factors. Which other factors? Industries. Industries are eliminating PM 2.5 particle, PM 10 particle level, and other air pollutants that are added and that are also measured. So what I will do, I will study how much air pollutants are eliminated by industry. Okay, I will measure that and I will subtract from my observation. Now suppose before beginning of study, I measure the levels of air pollutants because of petrol and diesel vehicles, and I found it as 120 cubic millimeter. After introduction of electric vehicles for 3 months, again I will study the levels of air pollutants, and average levels are 80 cubic millimeter. Then what I will do, I will study the levels of air pollutants because of industries. How much of air pollutants are eliminated by industry? If I found level by as 20 cubic millimeter, I will minus it from 80 cubic millimeter. So what number I will get? I will get 60 cubic millimeter. Initially, before start of study, the levels were 120 cubic millimeter. After 3 months, the levels have drastically reduced by 50%. It is now 60 cubic millimeter. So what I can say, in 3 months, there is 50% reduction in the levels of air pollutants because of introduction of electric vehicles. If you do not measure extraneous variable, which is extraneous variable of my study, here industry is the extraneous variable of my study. If you do not study it, then what will happen? You will have additional measurements. Additional measurement in terms of what? Additional measurement means you will get value of 80 cubic millimeter. It is 10 to 15% on higher side because of this extraneous variable. And you are not measuring the exact impact of independent variable on dependent variable. What are you measuring? You are measuring the impact of independent variable plus extraneous variable on your dependent variable. What is expected? What is required? You should assess the impact of your independent variable on dependent variable, and you have to minus the extraneous variables. In my case, I want to assess the impact of independent variable, that is electric vehicles, on the dependent variable, that is the air pollutants. But extraneous variables, that is industries, are also eliminating. Industries are extraneous variables that are also adding these particles. So I will measure the air pollutants which are eliminated by the industries, and I will subtract it from the outcome, that is impact of independent on dependent variable, that is 80 cubic millimeter minus 20 cubic millimeter. So I will get the pure impact, that is pure outcome of independent variable on dependent variable. That is the extraneous variable. So whenever you are conducting any kind of study, just see how many extraneous variables are affecting your dependent variable, because that will increase the magnitude or the value. Suppose I do not check the levels of independent variable dependent variables from industry, what will happen? I will get false result, that I will say that only 35% reduction. Actually, how much reduction is happening? 50% reduction is happening in the levels of air pollutants. If I measure extraneous variables, that is the air pollutants which are eliminated by industry. If I do not measure the levels of air pollutants which are eliminated by industry, I will say that there is only 35% reduction in the levels of air pollutants. And that is not the correct number. That is wrong number. I am not giving an exact impact of independent variable on dependent variable. I am not giving exact magnitude. This magnitude or this outcome is wrong outcome, because extraneous variables have also their impact added here. That impact I have to subtract or I have to minus it. Right? So what is here? I'm reading once again. Several other factors which are operating in real life situation. Those who are working in labs, they can control all their factors. But in many of our research projects, we actually work in real world. There we cannot control. You cannot ask someone to close the industry. It is not feasible. It is not possible. Right? So you cannot control it. But when you are conducting some experiment, suppose wet lab experiment or dry lab experiment in closed chamber, in that case, you can control everything. You can control temperature, you can control moisture, you can control all other variables. But outside you cannot control. In real life, you cannot control. Right? So in real life, there are many factors which affect your dependent variable, and these are called as extraneous variables. This factor, if not measured in the study, they increase or decrease the magnitude or strength of relationship between independent and dependent variable. So what they will do, they will either increase the strength or they will decrease the magnitude of the relationship or the impact of independent variable on the dependent variable. And it is must, it is very important. Right? So we take a control group. Why do we take a control group? We take a control group to eliminate or to reduce the impact of extraneous variables. This we will discuss in detail at the time of study design. But whenever we do study design, what we do in many of our research, we projects, we take control group, one control group or two control group. Why do we take control group? Because we want to control the impact of these extraneous variables on the dependent variable. For that reason, we take control group for our study. Next is intervening variable. Intervening variable are basically confounding variables or linking variables. So what does it mean by linking? Now, during our high school days, in chemistry labs, we have done a lot of experiments. So in some of the experiment, what we used to observe, suppose we have three chemicals, chemical A, chemical B, and chemical C. If we mix chemical A with chemical B, we do not see any reaction. As soon as we add chemical C, we see the reaction is happening. We see some reaction is happening, and that reaction is happening only in the presence of chemical C. If I'm adding chemical A to chemical B or chemical B to chemical A, there is no reaction. But as soon as I am adding chemical C to the mixture of chemical A and B, the reaction is taking place. And that is called as intervening variable or confounding variable or linking variable. Means my chemical A is independent variable. My chemical B is dependent variable. I want to assess the impact of independent variable on dependent variable, but there is no impact. They are not mixing with each other. They are not creating any reaction. I am adding third factor or I am adding third chemical, that is chemical C. As soon as I add this chemical C, in the presence of that chemical C, there is impact. The impact of A, chemical A is seen on chemical B in the form of reaction. And that is called as an intervening variable. Similarly, there is one more example. During Corona or COVID time, many people, like most of people, they had Corona infection. But how many died? Very few people died. Very small percentage of people died. So can you explain this? You can explain this with the help of intervening variables. Now, what is ideal situation? COVID-19 infection or coronavirus infection is independent variable and death is dependent variable. Means those whosoever is getting coronavirus infection should have been died, but it didn't happen. Why? There is no impact of coronavirus infection or independent variable, on death, that is dependent variable. It will require certain intervening factor or linking variables. What were those linking variables? You must have read in the newspaper. The terminology is like cytokine storm. I am just giving one example. Cytokine storm. So for explanation purpose, okay. So cytokine storm is a linking variable. Means those people with coronavirus infection who died, who had cytokine storm. Means cytokine storm is a linking variable. Among all those people who developed coronavirus, only those who faced or only those who had this cytokine storm were died and remaining survived. Okay, means there is linking variable. There is some link between my independent variable, that is coronavirus infection, and death. What is that linking factor? This cytokine storm is a linking factor or confounding variable, right? Similar to our chemical A and B. Chemical A will have its impact on chemical B only in the presence of chemical C. And chemical C is called as intervening variable or confounding variable or linking variable. So sometimes called confounding variable, it links the independent and dependent variable. In certain situation, the relationship between an independent and a dependent variable cannot be established. Means there is no direct relationship between independent and dependent variable. Like coronavirus and death, there is no direct relationship unless the person develop cytokine storm, or chemical A and chemical B. There is no direct relationship. There is no direct reaction. The reaction will happen only in the presence of chemical C, right? And that is the intervening variable or linking variable. The cause or independent variable will have the assumed effect only in the presence of an intervening variable, right? Means independent variable will have its effect only in the presence of intervening variable. If intervening variable is absent, there won't be any effect, or there won't be any impact of independent variable on the dependent variable. So this is first way of classifying, that is based on the causal relationship. Any doubt in this? Next is based on the study design. Now we will have separate chapter on study design, and we will deal in detail with different kinds of study design, quantitative study design, qualitative study design. So all those we will discuss in detail. But this is for the classification of variables. So type of study design, how it will affect the variables or how it will classify the variables. Based on the study design, we have active variables and attribute variables. So what is in by active variables? Those variables that can be manipulated, changed, or controlled. In my study, PM 2.5 particle level, PM 10 particle level, carbon dioxide, carbon monoxide, all these are my active variables because their values are manipulated. Manipulated means the change. Every day the value won't be same. Today, if it is 120 cubic millimeter, tomorrow it may be 70 cubic. Day after tomorrow, it will be 150 cubic millimeter. So the value is changed. The value can be controlled by introduction of electric vehicles. Right? So these are the active variables which can be controlled, which can be changed, which can be manipulated. These are the active variables. Attribute variables means which are attribute to my personality or which are attribute to the population. There are certain population attributes. Can you change my age now? You cannot change my age. That is my personal attribute. Can you change my education level? You cannot change my education level. Can you change my gender? You cannot change my gender. Right? Means these are my personal attributes. As a personal attribute, I am having certain attributes like age, gender, education, income that cannot be changed, that cannot be controlled, that cannot be manipulated. You can lie, you can hide your age, but once you tell the date of birth, you will definitely find what is your age. Gender, definitely there is no subjectivity. In education, there is no subjectivity. In income, there is no subjectivity, right? So all these are cannot be changed, cannot be manipulated, cannot be controlled. You cannot control somebody's gender, you cannot control somebody's age, you cannot control somebody's education, right? So these are attribute variables which cannot be manipulated, changed, or controlled, and that reflect the characteristic of a study population. So whenever we study a study population, there are certain attributes which are referred to that study population, and these are their age, gender, education, and income, which cannot be controlled, manipulated, or changed, which are called as attribute variables. Very easy to understand what is in by active and attribute variables. You already must have recorded these type of variables for your study. Based on the unit of measurement. Now our next topic is unit of measurement, and there are 4 types of measurement scales. nominal scale, ordinal scale, interval scale, and ratio scale. For today's purpose or for discussion of variables, just understand that categorical or discrete variables are nominal and ordinal scale. They fall under nominal and ordinal scale, and continuous variables, they fall under interval and ratio scale. So what is meant by categorical or discrete? Categorical or discrete means they are separate. There is no fraction. The best example is, suppose there are 20 people in the class, 10 males and 10 females in this class. I cannot say that there are 9.5 males and 11.5 females in the class. I can either say that there are 10 males and 10 females, 9 males and 11 females in the class. Okay, so that is a categorical, that is a discrete. There is no fraction. Fraction is not possible in the categorical scale, right? It has three subcategories. First is constant variable, second is dichotomous variable, and third is polytomous variable. Constant variable has one category. Dichotomous means two categories, and polytomous means more than two categories. So constant variable has only one category or value. An example is taxi, tree, water. That is only one category. There is no two categories or more than two categories. Dichotomous variable has two categories like male, female, yes, no, good, bad, head, tail, up, down, rich, poor. Means there are two categories like male or female, yes or no, good or bad. So dichotomous, the name itself suggests. And polytomous variables means can be divided into more than two categories, like religion, maybe Christian, Hindu, Muslim, Sikh. Okay, that is political parties, maybe BJP, Congress, Shiv Sena, Rashtrapati Congress. All these are political parties, multiple parties. When you measure somebody's attitude towards some aspect, so it may be strongly favorable, favorable, uncertain, unfavorable, or strongly unfavorable. Okay, so these are attributes. Polytomous, multiple attributes. Okay, you can divide into multiple areas or multiple types or categories. More than two categories, that is called as polytomous variables. Continuous variables, that is expressed in terms of scale, that is fractions. You can express in terms of fraction. Age, income, attitude score, you can express in terms of fraction. 44.2 years, or income maybe 10.5 rupees. Okay, 11.2 rupees. So that way you can express in terms of fractions. Whenever the things you can express in terms of fractions, and generally these are the quantitative terminologies. Age is quantitative, income is quantitative, attitude score is quantitative, and categorical, they are generally qualitative terminologies like male, female, yes, no, good, bad. Okay, expressed in terms of text or words. Continuous scale or continuous variables, continuous variables, they are generally expressed in terms of quantity or number or numerals, like my PM 2.5 particle level. PM 2.5 particle level, they are expressed in terms of numbers or numerals, right? And that is the continuous variables. Any doubt in this? Based on study design and based on unit of measurement? Okay, if there are no doubts, this is the chart. Categorical, we have three categories. Constant, only one category, water, tree, and taxi. Okay, on this side. Dichotomous means we have two categories. Yes, no, good, bad, rich, poor, day, night, male, female, hot, cold. And polytomous means multiple categories. Strongly favorable, favorable, uncertain, strongly unfavorable, or maybe political parties or age, old, child, young, income, high income group, middle income group, low income group. So all these are polytomous categories. Okay, discrete categories. Continuous means continuous scale. Income is a continuous scale. Age is continuous scale. Weight is continuous scale. Okay, so that is a continuous scale. Now coming to next classification based on the qualitative and quantitative. Qualitative means that is expressed in terms of words, and quantitative means that is expressed in terms of numbers. So gender, you have to express in terms of words like male or female. Maybe educational level, you can express high, average, or low. Or age, when you express as old, young, a child, it is qualitative. And when you say 42 years, 43 years, 45 years, it becomes your quantitative parameter or quantitative variable. Income, when you say high income group, middle income group, low income group, it is qualitative. And when you say 10 rupees, 15 rupees, 20 rupees, then it becomes a quantitative. Temperature, hot and cold, it becomes a qualitative. And when you say 37 degree, 40 degree, 50 degree, then it becomes a quantitative, right? So it is up to your study, what kind of study you are conducting and what kind of variables you are needed. Whether you read qualitative variables or continuous variables, quantitative variables for your study, right? That is based on the type of variables you have for your study, right? Any doubt in this?
Doubt was there.
Yeah.
In causal relation, like causal variables, you have explained about dependent, independent variable, and confounding. So, in all the studies, all the four variables are always present.
Not necessary. When you have a study which is based on independent and dependent variable, like when you study cause and effect relationship, Priya just
Correct.
now gave example of impact of social media on the marketing or on the businesses. So here there is causal relation, means there should be some cause and effect relationship.
Correct.
This type of classification is applicable only when you are studying or you are having a project where you have cause and effect relationship. When you want to study the impact of cause on the effect or outcome, that time you will have this classification.
Okay, sir. Fine. Thank you.
Any other doubt, anyone?
So we have to measure intervening variable also, right?
See, you have to identify the intervening variable. Now, during Corona, see, remember those days when the Corona started, like maybe in the month of March, it started March 2020. Initially, there was havoc. Everybody was anxious. Doctors were anxious. Health staff were anxious. People were anxious. What is this infection? How to treat this infection? Who is dying and who is not dying? But later on, people identified that people who are having some systemic diseases like diabetes or hypertension, they are more prone for ICU admissions, or the people who have cytokine storm, they will die, or there is more possibility that they will die. So this is after what? After identification. Initially, we had only two variables. One is independent variable, that is coronavirus infection, and second was death, right? Intervening variable, we have to find out. You have to study whether there is any intervening variable for your study. If there is no direct impact of your independent variable on dependent variable, right? And during study, you will come to know that your dependent variable is not directly having influence on dependent variable, and there are certain other factors that you need to study. So this is important landmark study like coronavirus infection and death. Why death is happening? Because there is cytokine storm. This is just example I have given. There might be n number of factors in case of coronavirus infection and death, but this is one of the examples. Like those people who experience cytokine storm, they died. Okay, so intervening variable, as an investigator, you are a principal investigator of your study, you have to find out whether there is any intervening variable for your study. Also, you have to find out whether there are any extraneous variables for your study. This you have to find out. This you have to dig out.